Small satellites, often referred to as smallsats or CubeSats, are revolutionizing both space science and commerce by providing affordable, flexible, and scalable access to space. Traditionally, space missions required large and expensive spacecraft, which limited the number of players capable of launching payloads into orbit. However, the miniaturization of electronics, improvements in propulsion, and advancements in communication technologies have enabled the rise of small satellites as powerful tools in the space industry. In the realm of space science, small satellites have opened new avenues for conducting scientific research. Their low cost allows universities, research institutions, and smaller countries to design and launch their own missions. These satellites are increasingly used for Earth observation, atmospheric monitoring, space weather analysis, and even interplanetary exploration. For example, CubeSats have been deployed to study the Moon and Mars, proving that high-value science can be conducted with minimal budget and mass. The ability to deploy constellations of small satellites has enhanced data collection frequency and resolution, giving scientists unprecedented access to time-sensitive and localized information. The commercial impact of small satellites is equally transformative. Businesses are leveraging these platforms for telecommunications, broadband internet services, asset tracking, and remote sensing. Companies like Planet, Spire, and Starlink are deploying fleets of smallsats to create global coverage networks, delivering near real-time data and connectivity to users worldwide. These capabilities support industries ranging from agriculture and logistics to finance and disaster management. The reduced development and launch costs associated with smallsats lower the barrier to entry, fostering innovation and competition in the private space sector. Moreover, small satellites are playing a key role in the democratization of space. Emerging space nations can now participate in space activities, conduct national security surveillance, and promote STEM education through hands-on satellite programs. Educational institutions use CubeSats as teaching tools, enabling students to engage in real-world space missions from design to deployment. Despite their advantages, small satellites face certain limitations, such as constrained power and payload capacity, shorter operational lifespans, and increased risk of orbital debris. Nonetheless, ongoing research and technological innovations are addressing these challenges. Developments in deployable solar panels, miniaturized propulsion systems, and autonomous navigation are extending the capabilities of small satellites and expanding their potential applications. Launch providers are also adapting to accommodate the surge in small satellite deployments. Rideshare missions, dedicated smallsat launchers, and deployers from the International Space Station are now commonplace, reducing wait times and increasing launch frequency. Companies like Rocket Lab, Firefly Aerospace, and Virgin Orbit focus specifically on delivering small payloads, reflecting a shift in the launch market toward smaller, more agile missions. As small satellites continue to evolve, they are expected to play a critical role in future space infrastructure, including satellite servicing, on-orbit manufacturing, and deep space communication relays. Their modular nature and rapid development cycles make them ideal for testing new technologies and conducting risk-tolerant missions that push the boundaries of traditional space exploration. In summary, small satellites are redefining the landscape of space science and commerce. Their influence is evident across scientific research, commercial ventures, education, and international collaboration. By providing cost-effective and versatile access to space, smallsats are not only enabling new discoveries and services, but also shaping the future trajectory of human activity in orbit and beyond.